Ground source heat pumps are pretty simple and very efficient. We notice more and more districts are incorporating them when they have a chance to rebuild a school. Here's how it would look if you had a ground source heat pump underneath your house.
Here's a diagram for a large system underneath a building like your school. Pipes carrying water are sent deep underground where the Earth's ambient temperature remains a constant 55 degrees or so in both winter and summer. The water in the pipes picks up the base heat from the ground so that the furnace in the building up above doesn't have to work so hard to bring room temperature up to a set point of, say, 70 degrees. That's only 15 degrees of heat it has to generate even when it's freezing outside.
In the summertime, it's opposite. The water in the pipes that picks up heat from the building circulates deep underground and cools back down to 55 degrees.
Once you drill the wells and install the system, energy consumption goes way down. Maintenance expense goes down too, because there are so few moving parts or mechanical systems exposed to the weather. Simple. Kent has 4 schools with ground source heat pumps, and 1 more will be coming online in October.
Bellevue has 3 elementary schools with ground source heat pumps, plus 1 more under construction.
Lake Washington has 3 schools with ground source heat pumps, all under construction.
Renton has 1 school under construction with a ground source heat pump.
In our research, we are trying to figure out the right ways to measure whether or not we are making progress on managing stormwater as part of the built environment. This is a crucial mega trend to pay attention to, because 75% of the pollution causing ecosystem decline in Puget Sound is from the rain that washes pollution off our rooftops, driveways, parking lots, and streets, concentrates it in pipes, and flushes it straight into a nearby stream or lake. We need to be able to design our buildings to infiltrate stormwater slowly through healthy soils and native plants, back down into groundwater, like a forest. But how do we ask the right question? Should we measure the number of schools with demonstration rain gardens? Should we measure how many school parking lots have bioswales to intercept, filter, and infiltrate the oils and heavy metals from hundreds of cars, plus the daily lineup of diesel-dripping buses? Maybe the most accurate measurement would be to have all of the school districts in our watershed report on the percent change in impervious to pervious surface, hard surfaces that don't infiltrate compared to natural surfaces that do. We will try to establish these benchmarks for next year's Sustainable Schools report. For now, the mega trend of stormwater pollution solution is being modeled in the Lake Washington School District.
This is Finn Hill Junior High. Notice the curb cuts. Notice that at the end of these parking strips, there's no curb at all. Rainwater that picks up pollution from cars will easily flow off the edge into these long bioswales currently under construction. The bioswales will be filled with rich soil and compost and planted with drought-tolerant native plants. The microorganisms that will thrive in these soil conditions will break down or bind up the pollutants. Notice the pavers along the walkways where rainwater can soak through the cracks in the bricks and seep down into the groundwater, filtering and settling. The same principle is at work here. Notice that none of these roofs have gutters. The rain will fall off the lip of the roof into a strip of gravel below like an old native longhouse. Almost all of the stormwater at Finn Hill Junior High will be infiltrated on-site. The groundwater will be recharged and the whole thing will behave like a forest again. This is a perfect example of what we mean by the second of 3 state standards for environmental and sustainability education. I understand the relationship between the natural and built environments. Bingo. Puget Sound starts here.
As of June 2011, how many schools in our watershed had solar arrays? And how many total kilowatt hours were being generated per year as a result? Tahoma has 8 school buildings. 1 school has a small solar array generating about 800 kilowatt hours per year. Kent has 38 school buildings. 1 school has a 2.4 kilowatt demonstration solar array generating 1,412 kilowatt hours per year. Mercer Island has 5 school buildings. 1 school has a large demonstration solar array generating about 2,000 kilowatt hours per year. Seattle has 84 school buildings. 3 schools have arrays, with data available generating about 2,000 kilowatt hours per year. Renton has 24 school buildings. 2 schools have solar arrays that generate a district total of 5,000 kilowatt hours per year. Renton also has a new high school under construction that will have a large passive solar array that will preheat hot water for the building. Issaquah has 24 school buildings. 1 school, Liberty High School, generated 2,310 kilowatt hours during the 2010-2011 school year. North Shore has 31 school buildings. 3 schools have solar arrays. Together, the North Shore School District generates about 7,200 kilowatt hours per year. Bellevue has 27 school buildings. 1 school, Interlake High School, has a 4.2 kilowatt solar array on the football stadium concession stand, which generates an average of 3,700 kilowatt hours per year. Cherry Crest Elementary, now under construction, will have a 99.9 kilowatt solar array capable of generating 89,910 kilowatt hours per year, or almost 90 megawatts. Lake Washington School District has 52 school buildings. Last year, the district generated a total of 29,600 kilowatt hours with a 12 kilowatt system on Evergreen Junior High School. In the fall of 2011, Lake Washington will be switching on a 355 kilowatt system on Finn Hill Junior High, which will be, by far, the biggest solar array on any school anywhere in Washington State. On an annual basis, the school will be capable of generating 319,000 kilowatt hours, or 319 megawatt hours. This means the building is nearly net zero for energy consumption. Zero. New high-tech meets old Mother Nature. Balanced, sustainable. Lake Washington School District is leading us all into a future where our schools become solar energy power plants. It makes sense because the roof span of a school is the biggest exposure in the neighborhood. Why not take advantage of it? Maybe neighbors could even buy shares in the production. Just thinking.